To linked lists part 2 of our video series. In the first series we learned again about object references and the idea of separating between the variable that's holding the memory address to the object and then where it's actually physically located in memory, and realizing that we have this link between them that we have to get used to. Now in that video we just manually built structures, but we couldn't really go more advanced with making really long structures without having to have an individual reference to every object, which is not really that useful when it comes to a lot of these link structures and data structures that are built up of them. So what we're going to need to do is build and use another tool called the moving reference, where we take one of those object references and how we can get it to move from node to node in this linked chain environment that we have. And that's what this video series will cover. So a moving reference, so it's a reference variable or object reference variable that can be used to step through a previously created structure. So where you will generally have generally you'll always have some kind of beginning reference that holds a link to the start of the list or some component within the list. And then that will go to the first node, and then this next node will link to the one after it, and then the one after it, until we reach the end with null. And then you have the moving reference itself, which is just a reference variable. So it's not an object, it's a variable that can hold an address to an object itself. And then this one can be used to start at the beginning and then move in the direction that the chain starts. So since this one's going all to the right, this is one that we can then start using to move to the actual right. So this is useful for cases where only one original reference is kept to hold a larger structure of nodes or objects, and all the data must be accessed or worked with at some point in time, and that list must be manipulated to add or remove or find actual nodes. So key to a lot of the work done with linked lists and many other link structures are these actual moving references that we use to temporarily hold a link to an object that we currently want to work with. So for a singly linked list, this is just a node class for a singly linked list, and it's a generic one, so we can see where we can store our data. We only have one object reference that we're going to be linking to the object that should be after the current node, and you have some basic getters and setters for the data, and the same thing to access to modify the actual the node next reference or get what it currently references to. So let's look at a smaller example where we'll set up a small linked structure here, and then have how can we get a reference to move through it. So here we just have a small main. We have single step here where it's going to have our build link structure. So this will be a function that just builds the current link structure we want to set through. And we can see here where we're setting a reference, an object reference right here, set to null, being it's not referencing anything yet, that we're going to use to move through that structure. The build structure up here that we're working with is basically just setting up one node link to the next one. So it makes one reference. You can see we're making the node called node 1, and then we have reference.setNext2 where we make a second node and automatically link that to the previous one, and we return the start of that list here. Next, after that, we can see where we're doing things like mover equals start, where it's referencing the beginning of that actual list. So we're not copying the object, but we're making that we have two object references that point to the first node in the list. We keep start here, so it's always holding on to the beginning of it, and then we will use mover to go through to the next node. And this one down here is the actual step where we go to it. Now, I expect as you see the previous videos, even though I talked that quickly, we have a step-by-step of going through all of the actual code itself with the visualization happening here. So in step 1, before this line is actually executed, we have our start reference, which would be null, and then we have the call to the method here to actually build the structure for us. This one here within the first line for the reference that we have right here, we'll make a new object that we see here, and passing the data is node 1, and that it sets in the constructor the next reference to null. After that, we have this one line inside of here is that this gets executed first. Right here is the new node at node 2, which makes a new object, gives it the data node 2, and sets the next reference to null. The reference for that is then given back to the set next reference here, and we're going reference dot. So we're going from reference over to here, and we're changing the next reference that's in here. We'll be referencing down to the one that was just created. Boom. So after this line, what we have is a link structure with one node linking to the next, and reference is holding the beginning link to that very first node. So when we return it back here, we're returning this reference, which links to this one, and then we'll still have a link down to the next one. So we're coming back here, and now that's assigned into start. So even though it was made up in the reference here is the idea that beginning reference address was copied and now stored to start. So now start referenced the beginning of this node, and this node still references down to the next node that came after it. Here again is that mover node. We're setting it to null in the beginning just because we're not linking it in. It's good practice to start with, and just showing then that first step of it being created. Next we have mover equals start. And so start currently references this node, so mover will now reference this node right here. When we go down to the next line, it's system.out.print line. We have current node plus mover.getData. So again, I go look at mover currently is here. We go dot, so we follow its arrow up. So it means it's calling the actual getData method on this node right here. And that data is that string node1. So node1 gets returned, add concatenated with the current node string, and then print it out. So that's our first print statement. This next line that we're going to go down to here to mover equals mover.getNext is the step of how we're going to go from one node to the next. So here first is with the mover.getNext. What this is going to return again is following mover dot. So we go where mover is, follow its arrow up to here, and it's doing .getNext, so it's going to return the reference that's currently stored in here. And that's marked what we have by the actual blue line or the arrow that we see here. Next is referencing to this object down here. So that means then that this line, the mover.getNext, is going to return the reference back to the next node. And then that is assigned into mover. So we've done mover.getNext, which gets us to here, gives us this reference, and then we go back and it's overriding the previous value that was then in mover. So basically this is it stepping forwards. So we have next, and then it's copied over, and mover. So after this line right here, mover is not pointing to the first reference now, it's referencing the next node that was after there. So when we go down to the final line right here, we have current node. Here is then mover.getData. So following the actual arrow down to here, it's going to get the data that's out of this second node that mover is currently referencing, which will be node 2, and we see that moved, printed out to the screen. So you can get kind of the gist that this mover equals mover.getNext is going to be very important for starting at the beginning of a list once we have a reference, and then stepping one by one through the nodes in the list. So it's kind of our way to move forwards. And then we need to set up other code then to control, well, when do we stop, and what are we doing once we get to that location. So here's a multi-move step, so taking that same example that we said before, but instead of just having one node, we have like one node linking to another node, we have multiple nodes in this case. So in our build link structure, one here we have one node, we have a second node, and we have a third node that are linked together in a linear structure. And then we have the same kind of moving steps we had before. So I'll go through this one a little bit faster. So beginning, start would be null. Then the build link structure method is called. Once we're in the build link method, we go through all the way to the end, is that when we're by the end, this is the current structure that we have here. Is references to this node, temp reference to this node, and this last node down to here, and we have them all linking down. Here in the end is return, we're just doing the reference, so it returns the address for this first object. And reference and temp reference are local variables, so after this method call they'll disappear, but we'll still have all of these because these were allocated in memory, and we'll still have access to them. So when we come back here, is that entire structure, the link to the first node is saved into start, and then we still have the rest that are linking down to each other to create the link structure, and we have our mover reference set to null in the beginning. And now to start stepping through the entire list, going from the beginning to the end, we start with the first reference because that is the only one that we have access to. So here is we don't have direct references down to here. We can visually see it in this diagram, but in the code-wise, we only have this first reference to enter the actual list, so we can't jump randomly. So we must start at the very first node we know access to is which start. So we get mover equals start right here. Next, we can print out the data as you expect. Mover is referencing this object, so it prints out node 1. The next line is going to be mover equals mover.getNext. So up to here, next is here. So the address to this one is then overwritten for the previous address. So the idea is basically we're stepping forward to the next one we see here. So boom. So steps forward to there. Prints out the message. So mover is currently on this one, so it'll print node 2. And again, repeating is the next line is mover equals mover.getNext. This will then go in, get the next reference, which is referencing to the object down here, store it back here, so in effect moving the reference forward once more. And we're at the end, and then the final print, which you expect is node 3. So you can see that linear structure of stepping through from the beginning of accessing, setting it to the start, accessing the data if we need to, and then going next to move to the next reference, and then the next move to next reference. And it's always this step of whatever you're using as your moving reference is going .getNext and then storing it back into the original variable. So accessing where you're currently referencing to link through to the next one, since each node is holding the reference to the next one that follows after it. So with this linked structure, we could also detect the end of the actual list itself. As we said, is that the last node will always reference to null. And so we know that, okay, well, if the current next reference is not null, there's one more node. But if the current node we're looking at, its next reference is null, means we've hit the end of the list and we should actually stop. So we can now rewrite that original code we saw before for stepping through that link structure that had multiple nodes. Now instead of having to hard code and copy and paste a lot of it, we can now use a loop method to actually step through it one by one and stop when we detected that we've moved off the edge of the actual list itself. And so you can see that example here. So moving the list, we have the start, and we can check if it's not null. Okay, well, start's not null, so there's something. So go in, access the data, move to the next one, and before we're going to access again, check and see if we haven't moved past the end of the actual list. So this now we could move through any number of nodes and any type of this link structure moving in that one direction. So I'll go through this example quicker again. So this is using a similar one before where we're doing a start node and build our link structure. So this is the same one we just had previously in the example where there's just 3 nodes within there for that start reference and 3 nodes going down. We have mover set to the very start. We check, is mover not equal to null? Okay, true, it's referencing something, so start was actually referenced to here and it wasn't just an empty list. We go in and print the actual data for the current one that we're referencing. We then move the reference to the next one, and then we go up and check, do we still have more nodes? Okay. Mover here is referencing, it's not null, so there is actually something there. So go in and print the data, move to the next one, go up, check, okay. Do we have still another node? Yes. So go in and print the actual data, go down, move forwards, and now after this is we've got the next, but that was null, so then mover will be set to null. So the next time we go up, okay, well it is null, so this will end the while loop and exit out, and we're actually done. So we've reached and gone through each element one by one, and then stopped when we've detected that the mover itself is gone off the end of the list. Now this would be very useful. So again, going through, if we have to go through every node, we can modify this actual loop if we need to stop at a certain point in time to create a counter that stops when we hit a certain condition. We can also use mover just to check is the next step to move. So maybe we want to go to the end of the list, but not completely leave the list, just go to the last node and then stop. Well, we can always look at the current moving reference and check, well, if mover.getNext is null, then we know the next step is the end of the list, so we can stop when we have a reference right at the end of the list itself. Now, we could also rewrite the building method to make longer chains of any size using a moving reference. So the idea is that we can move to a certain spot or keep moving it forward to keep a marker of where we currently are. So here's a building one where you give it the number of nodes and it'll keep making a list of the number of nodes that you have of your size. So as long as they're given a number that's greater than 0, it'll go through making the first node, so node 1. And right now what you'll see is we have temp_ref and current_ref to use as temporary variables to do our work. Temp_ref will be used to make the new node we want to add to the list, and current will always hold the current spot we want to add at the end of the chain, and reference will always hold the chain to the start of it. So we always have to have these multiple points to hold on to things as we do work and not lose them. So here we'll make reference as the very first node. We set current equal to that actual reference itself so that we have two things connecting together. We then start, okay, we'll assume that's one node, so if we go from here, starting count at 2, we'll go up 2 and equal to the number of nodes they actually want, and adding to that is we make a new node, save it to this reference, current, setting its next, so current will always be pointing to the end of the list, and so to link it to the new node we want. And then here you can see where we have current equals temp_ref is we're then moving to the actual next node itself. And then done down here. So let's just do an example, say with 3, so building that similar structure we had before, is that we can see we have these first 3 references in the beginning, so reference set to null, temp_ref set to null, and current set to null itself. Here, number of nodes is greater than 0 because that is 3 for what's passed in, so we have reference equals new node, so that's the new node that's made with the actual data. We have null. We then have current referencing this, and again we're going to always keep it that reference will hold the very first node in the list, which one was made, and current will be always holding the reference to the current node we're at, where we want to add one after. So we've only added one node, so that's why they both reference the same. We go in and we've got count equals to 2 to start with. We make a new node and we currently reference and use temp_ref to hold on to it, because we want to keep reference here, we want to current here, so we need a third one to temporarily hold this node so that we can do work with it to link it properly into the structure. Current.set next is going to take from current, so whatever is the current end of the actual list, access its next reference, and then make it equal to the new node that we've actually created. And so what we want here is reference will not move. We've now made this here, and this is going to be the new end of the list. So now that we've linked this here, we now then need to move current so that it's referencing this end of the list. So we have different ways we could have gone about this. We could have now gone, since we linked this together, we could have gone current equals current.getNext, because you'd have current and then getting its next with reference down to here. But we also have temp_ref right here, so I'm just bypassing that. We know, okay, temp is always going to hold the current node we're adding, which would be the one at the end of the actual list. So we'll just set it equal to that one, and they're both those same steps. And we're left here after one iteration, then we have current node, like the first start node we added, the new node we'd added here, reference is still pointing to the start, and current is still pointing down to here, and temp_ref is currently pointing to the one that was created, but that'll change in a second. So go back up, still have iterations to do, because now we're count 3. From right here, make a new temporary reference to right here to make a new object. Setting current where it currently is, next reference to that actual node that's down here, and then moving that reference forwards. So you can see the idea of where these moving references and understanding object references will be useful as tools to temporarily hold on to structures as we're building them, and also the points where we want to actually add or if we want to move through the list. So this will take practice and it's important to keep going through. And you can see the last one, we are done. We've got the 3 structures that we actually need. So this was a quicker, shorter video, but just showing you first, well, this is a little tool of that moving reference. So just having a reference that will be used not just to hold on to one object, but to step through into different parts of the actual structure where we can loop or go to a certain point, and how to move from one step to the next. And also having multiple object references currently holding what we want to work to. So we have like links to hold on to the current node we want until we have it in the place we need in that structure. And then always being careful to keep where we have for our start and other points where we're adding. From there, you should stop, and now we're going to be moving on next to the final video in this series where we go through steps of building up a singly linked list, bringing everything that we've learned so far into this for the actual object structures and then object references, and then actually having object references that then can be used to move through a list, and even bringing together everything we've learned about comparators and the actual Java generics. So continue on to the next video and continue being great people.